Okay. Now I'm making you presenter. Yeah. Now can you share your screen? Yeah. And I'm taking your control. Okay. I got the control. Your machine is slow a little bit. Right. Are you controlling the machine?
Yeah, I can control.
Okay. Let me type. I'm not able to type. Okay, so you can do one thing. Okay, go to the browser. You have installed Linux Mint, right? Okay. I'm not able to type. Okay, so did you open browser? It is in background something processing.
If you need to close, can or running this one package.
Okay, let me, I do on my machine. Really. Today my machine is getting very slow. Okay. What? It's not that much slow. Okay, you share. This is giving. I just okay. Yeah, you are host now. Sheikh.
I am the one.
Hmm. Rishikesh, have you installed Hive? Hello.
Shall I download the file?
Yeah, hello, Sheikh. Are you able to share?
Caesar.
Okay. Yeah, open the browser. You can cancel this installing software because it is, or restart the machine, restart machine. Yeah, because this will hang up the lot of suspend. Power of event. Okay. Yeah, start machine. Richard, have you installed Hive? Richard?
Yes, I have.
Have you done or still pending?
It's hanging towards the DBFS.
Okay, you share screen and let me check. Okay. Yeah, and your Hadoop is running, right?
Yeah, the Hadoop is running. Yes. Let me start my machine. Yes.
Okay. Okay.
I'll share.
So if you can control my screen.
Actually, I'm just checking just once, Richard. Okay. And Richard, if anyone is asking for to admit in the meeting, just allow that. Okay.
Yeah.
Okay. Just I take. Okay. Okay, I take the control.
Okay.
Okay, so these are the unwanted one. Okay. So first we started Hadoop, okay, for installation of Hive. Why it is saying start all.sh?
I don't know what is going on.
Your Hadoop is not there.
The Hadoop was installed, it was running. Why? What happened?
Okay, Sheikh, you share. I think your Hadoop is not there, Richard.
Check the rights and see if it has anything to do with it.
Okay, now you share screen. Sheikh. Okay, you open the browser. Actually, I don't. Okay, I have control. Can you open the browser? Sheikh, are you able to open the browser? I think it is okay. Going to complete. Okay. Okay, I think the machine is. Okay, so you guys are able to see my screen, right? Okay. I'll do the reinstallation on my system. Okay. Okay, I'm starting the Hadoop first. Okay, and I will follow this document. Okay, this website documentation. So how to install the Hive on Ubuntu. So first of all, the prerequisite is like we should have the JDK. Okay, so once we have the JDK, we already done in the Hadoop installation, the Java installation, right? We have already installed. Now we go to the official web page of the Hive. What is the latest Hive version? Okay, so here we go to the release. Okay, and here we'll see the latest release. So 3.1.3 we can install. Okay, so we download this folder. Here is a bin tar file. We download this tar file. So I have already this 3.1.3 folder I downloaded. Okay, so I have extracted it and keep it in the home software folder. Okay, so here I kept it this Hive 3.1.3 folder. Okay, next thing is I have to set the home path. If we see in this documentation, we have to set. So this all part I have done. I have downloaded the Hive. I have untar it. Okay. So this is the older release, but we are installing the 3.1.3. So once this is done and we copy it into the software folder, next thing is we have to set it this Hive path. Okay. So I have to copy this and I have to go to in the bash RC, I have to set it. Nano PASHRC. And here I go into the bottom. So here I have already set it, just I'm showing to you. So mine is Hive path is. This is the Hive path. So this is the Hive path, Hive home and export path. Okay. So these two paths, right? Hive home path and bin path you set, and then you come out Control X, Shift Y, Enter. And after that, we have to do the source command, PASHRC. Once this is done, we are this step number 2. Okay. Once we done this step, okay, then next is we have to create this Hadoop directories. Okay. So I'm recreating this Hadoop directory. I'm just creating this mkdir temp directory. So mine is already exists, right? The temp directory is already there. And I need to give the permission. So we have to give the group level, right permission I have to give. Okay. And the next directory is user warehouse directory. So user warehouse directory is a default directory. It's an internal like a meta store directory, right? Or table there the data is stored. Okay, for the internal table. Okay. I will talk about what is the internal and external table and the partition bucketing. So these concepts will come. So here I'm creating another directory, but this directory is already there. Okay. So this directory is already there. So this is showing mkdir. So this directory, and then I'm just going to set the permission on this directory. I'm going to set the permission on this directory. So once these two directories are created and the permissions are given, okay, then permission is given. The next thing you can do for the Hive is we have to go to the conf directory. The conf directory, it is saying we have to change Hive default XML template to Hive site.xml. So if we go to here Hive conf, so here is a Hive default. So I have already changed it, Hive site.xml. So Hive default text like this file, default XML template file to change Hive site.xml. And once this is changed, then we have to run this schema. We have to initiate the schema. So default database for the Hive is Derby. So Derby is a database which is used to store the metadata information, metadata, right? So we are using Hive. Derby database is a metastore DB. Okay. So we have to run this command. Okay. So mine is it is there. So first I remove this. Okay, I do with the new one. This is the metastore DB. So my software folder. So I changed that hive default.xml to hive site.xml. Hive site.xml. Okay, this is done. Okay, so it is showing me line number 3215 in hive site.xml. There is some issue. So I will open this hive site.xml. So I go to 3215. So there is some special character that I need to remove. So this is a special character. So this is a flaw already there in hive site. So this one I have to do. Then I run again schema. Okay. So if you see here the steps, this step when I'm doing it, so it is coming like this. Okay. So this part is done. If you have any Java compatibility error, then you have to run this. This fix is there. So you have to copy the Hadoop lib directory. There is a version 27 that you can copy to the hive lib. Okay, but we don't need to do. We didn't get any error. Now we will start the hive. Just simply I will type hive. So one more error I am getting. So this error how to fix? I copy this Java IO temp dir. I go to same hive site.xml and here I will search it. So I have to remove all those specific properties. I have to remove it. So this property is having this Java IO temp dir. Even description is fine. It's not a problem, but we will remove all the properties. Okay, so there will be no confusion. So this is the one. Again, I search. This is the one. So remove very carefully because you have to remove starting property and ending property. Okay. Otherwise your XML will be distorted. So this starting property, this is having Java IO temp dir. So I removed it. And one more also. Total 5 places. You remove this and save it. Now I will try hive. Okay, so this time my hive should come. Okay, so once your hive comes, so you can start with the show databases. So you can see default database is a by default database is given by the hive. I want to create my own database, create database testing. So I created my database. I can use a database and then I can go tables I do, I will not find any table. So I have to create a table here. Okay. This is clear. So this is the, so here some steps are missing. The last error which is coming Java IO temp dir. So that error is not there in this document. Okay, so that error and otherwise the steps are same. Okay, so this is for installation for hive. Okay, so now next thing.
The start program is.
What?
I said it's now working, but I don't know why it didn't work when it tried it.
Okay, now hive is installed, so I just do the other implementation thing. Okay, yeah. Let's continue on mine one. Okay, so hive I have installed. So next I will do all the practical. Okay. Okay. So first thing is in the hive, I'm going to start the complex data type. Okay. So Okay, first internal and external table. So first we understand what is the internal and external tables. Okay, there are two types of tables. So Hive we deals with, first we have the database. Okay, so database is like a collection of the tables. Database is a collection of tables. Okay, and the table is having the rows and columns, right? We are all know these all concept, rows and columns. The rows we call record, rows are records, okay, and columns are field. Columns are field, the table, okay, and it's a table representation of the data. Columns are the field in table, okay, and table is a record and column of collections, okay. So there are two types of table, internal and external table. So when we create, there is no external keyword if we use in the create table syntax. If I use create table, my table, or if I use create table, create external table, my table. So if this table, if I'm going to create, this table will be internal table, okay, or we call it manage table. Okay, this manage table is stored by default in the user hive warehouse directory. So user hive warehouse directory is a internal directory for the manage table. So user /hive /warehouse directory. So here this internal table will be stored. And when I say the external table, I'm just specifying the external table, I'm specifying the location. Okay. So when I create an external table, I will be defining the location key. So here location, and I keep the some Hadoop location, my location. So this is a Hadoop location. So this external table will be stored in the some external location, okay, in the Hadoop directory, external location in Hadoop directory. Okay. So whatever Hadoop directory I am giving, that external location, it will be stored. The data will be stored there. Okay. And there is a one big difference is there in the internal table and the external table. When I drop internal table, the data and schema both will be deleted. Data and schema both will be deleted. Okay. But when I'm dropping external table, okay, drop external table, so only schema is deleted. Only schema is deleted, not data. So we can recreate table from same schema. Okay. So if I run the create table syntax again, create external table, and then I create a syntax again, then it will recreate the table and with associated data, whatever location the data is present. So that's the main difference. I will show practical of internal external table. Okay. Okay, so first we understand what is a Hive architecture. Okay, so what is a Hive background? Okay, Hive is initially created by the Facebook. Okay, and later it is given to the Apache community. So now it is the Apache Hive, and the latest version of Apache Hive is a 3.1.3. Okay, and Hive is a completely SQL data warehouse tool. SQL data warehouse tool. So what is SQL data warehouse tool? It's the same like a SQL, but having a additional capabilities are there like partitioning, bucketing, Sardis, UDF. So these are the additional capabilities on top of the SQL databases. Okay, and Hive is running in the background MapReduce job. Hive is running MapReduce job in background. Okay, we are not creating any MapReduce job. Hive is internally creating. So what is Hive architecture? So if I broad level Hive architecture is, so we have certain components are there in the Hive architecture. So if I say one is a Hive CLI, this is a user level interface are there. Like one is a hue is there, like I can connect with the hue. It's a graphical user interface, and we can generally it is in the Cloudera. If you are using Cloudera CDH or CDP, there you will get the hue. Okay, this is a proprietary tool of Cloudera. Okay, and Hive CLI is common. Hive CLI is like this is a Hive CLI. So whatever I installed it, this is Hive CLI. This is a Hive CLI. So this Hive CLI is a one way to communicate your Hive backend. Okay. Another one is Hue is there, and third one is a B line. So B line command line. Beeline is generally sometimes the Hive access is not given to everyone, because Hive is anyone can access Hive and it can change, someone can delete or remove any internal table or anything. So they are not giving direct access to Hive shell. They are giving the Beeline command. The Beeline command you want to access with your username password, your LAN username password, you access this Beeline. It is a thrift server. This is a thrift command line server. Thrift command line server, CLI. Okay. So here you can run the same command. Whatever I run in Hive shell, same I can do on the Beeline. So your Beeline will be your shell, like Beeline like this. And then you can run your Hive shell command. Every same command you can run here. Okay. So these are the interfaces, like how we can communicate to Hive. After that, once Hive is basically receiving the queries. Okay. And this query can be a select query, update query, delete query. So it will be a query only. The user is giving query. Okay. So when user is writing a query, write query and given to the Hive, and Hive is having a compiler, Hive compiler. What this compiler does? This compiler is compiling the query. It is just verifying your syntax of the query. Suppose sometimes I have written the wrong syntax. Okay, I have just written something TBLE. So this will be a wrong syntax. So syntax is verifying by the Hive compiler. There is a Hive parser. Okay, Hive compiler, Hive parser, that is a parsing your query and converting. So there is a phases are there. So once Hive query comes, it is compiled, then parse, and then convert into in the MapReduce plan, right? MapReduce, okay, program, and then finally this is executed by Hive engine. Okay, so Hive engine is not executing the MapReduce plan. So this MapReduce job is basically converted. But here is a one more component is there, Hive engine, database engine. So database engine is basically executing your query and converting into this query into MapReduce job. And then MapReduce job is running in the background. Okay, so database engine, Hive database engine is basically similar to the SQL database engine, like which is executing your query once after compile your query and parse your query, and then this database engine is it's executing your query. So one more component is there in the Hive is meta store DB. So Hive is having two things. One is actual data. Actual data is stored in the HDFS. So HDFS is a Hadoop distributed file system where your actual data is stored. Like either it's in user Hive warehouse directory, or it could be a external table location, user Hive warehouse directory or external table location in HDFS. Okay, but there is one more data store is there, meta store DB. Meta store DB is a Derby. Derby is the default database for meta store DB. So this meta store DB having a one table TBLS. So this TBLS table is keeping the information about the table type. Table type. The table type could be a managed table or external table. Okay, external table. And column types, column name, column names, column types. So these all informations are stored in this TBLS. Okay. So when you are writing a query, so the meta store DB is connected and it will be found this information about whether it's a managed table, column names, column type, and database engine is finally running the query. Okay. So meta store DB has the three types are there. Okay. One is local meta store, local meta store. One is embedded meta store, and third one is a remote meta store. Okay. So when I say local meta store, it's the same like Hive has provided, that is inbuilt, like Derby. I say that is local to Hive, local to Hive. So Hive is having this Derby database, and that is That is local to Hive. Okay, this local meta store. Embedded meta store is like multiple JVM, right? Service, but machine is same. Okay, like multiple JVMs can be there. Okay. Okay, so this embedded can be Derby also, or we can configure any other SQL databases like MySQL. Okay, so here we have the option in the embedded one, but the remote meta store, we have to use some external metastore DB, which is not part of your Hive, that is separately running in your machine, right? So that you could be having MySQL, Oracle, SQL Server, any DB name you can change, but you need to change in your Hive site.xml. So somebody asks you, how can you configure your remote metastore? So you have to say there is a DB information is there. If you go to Hive, so in Hive there is here in Hive site.xml. So if you search here, store. So DB. Okay, Derby we search. I think that is okay. So if you search Derby, yeah. So Hive metastore DB type is Derby. So this property information you have to change. So whatever database you want to configure, you have to change the URL, username, password. So all those information you have to change. This Java X JDO connection URL. So you have to give that particular database metastore information. Okay, what is your database name? So this is a default DB name, but you can change this DB name also. Okay, so if you have seen in once I installed this Hive, okay, so metastore underscore DB is created. So one folder is created in my local file system here. In my one folder is created with the name metastore DB. So this metastore DB is metastore DB. So this metastore DB is having this all the table information. Okay, metadata about the tables. Okay, so this is the use like how we can use the remote metastore. Okay, so this is clear. So hivesite.xml, we have URL, username, and password. Okay, so these information I need to change for external metastore DB. Okay, so after the Hive architecture, so these are the all component is there in Hive. Hive is having one Hive server 2, like two servers are there. One is a Hive database engine and one is a Hive server 2 that is called thrift server. The thrift server is sometimes you want to connect Hive with some other operating system. Suppose I want to connect Windows, or I want to connect them different programming language. Okay, so Hive thrift server comes in picture. Thrift server is not a Hive proprietary thing. Thrift server is common thing, but which tool is providing the thrift server? Like hbase is providing thrift server, Spark is providing thrift server. Thrift server means like it's providing a thrift protocol. Thrift protocol is like connecting to two cross platform, two different platform you want to connect. So suppose I want to connect with Tableau with Hive, and Tableau is running in Windows, and I want to connect Hive in my Ubuntu, so I can connect by using thrift server. So thrift server is basically using the thrift protocol. It's using the thrift protocol. Okay, that is converting call from the one platform to another platform, right? Okay, so Hive server 2 is also a one server. When you want to connect to JDBC program, you want to connect, right? Suppose I want to connect programmatically Hive, so I need to use a JDBC program, JDBC ODBC driver. So Hive is providing its own Hive driver. Hive is having its own URL, password, like so this all this, like I told you in a beeline, the same parameters you have to provide these to connect to the Hive by using the programmatic way. So you can use the JDBC ODBC driver. Okay, JDBC ODBC, this Hive driver you can use to connect your Hive thrift server to the your Hive backend. Okay, so these are the main component in the Hive. Okay, now we come to okay, let's do the practical of the internal table, external table. So when I'm going to create a internal table, Okay, so just I'm showing you one internal table, like I'm going to create this internal table, create table test. So I'm not using any external keyword. Okay, so create table. I'm going to create this internal table. Once the table is created, you can do the show tables command. You can see the table is created. If you want to see the table schema and you want to see the, okay, first you want to see the table schema, describe command is there. So describe command will give you the table column information, right? Column name and column type. But you want to know the full table, create table command. So there is a command show create table. There is a command show create table, and then you can give the table. When you do this show create table, it will give you the complete create table syntax. Okay, and it will tell about the property of location. So location is by default is your warehouse directory. Okay, so when you want to see any this particular directory, okay, right now this directory will be empty, right? This is a directory of location of your internal table. So how can we run the Hadoop command here? So you can use exclamation mark, then you can write Hadoop fs minus ls, then you slash, you can give this location. Okay, so this is the internal table directory location, the warehouse directory, and this location you can see right now no data is there. Okay, the data is already present. Okay, by previous hive. Okay, it's not clean up. Okay, so I just create the another table because this test table is already there. So I give test table. Okay, so this table test 1, 2, 3 is created. Now I will change here the test 1, 2, 3. Okay, so this directory will be empty because I have not inserted any data. I have not put any data in this table. If you do select star from table test 1, 2, 3, so there is no data because I have not inserted, just I created table. So when I created table in my user local warehouse directory, there is in test 1, 2, 3. So how it create a folder? So user hive warehouse, and there is a database, and inside the database, it is creating the table folder, and this table folder, it will be writing the data. Okay, so there are the two ways to load the data into the table. There is the one way you can load the data from the file. You have the load data local command, and then you can load the data, or you can load the data from table to table, like some other table to one table, like you can load insert into table command. Okay, so there are two ways you can load the data. Okay, so first we look at loading this internal table data from the file. So suppose I have a file. Okay, so this is my empty directory. I will create a file with this data. So you know how many columns are there in this table? Two columns, ID and name. So I have to prepare the data, comma, delimited character, because I'm creating a table, create table, and then I'm giving a fields, and then I'm specifying row format delimited, fields terminated by comma. So I have to prepare the data like this, name, ID, and name. Okay, so I'm creating a one file, internal.txt, any name you can give, then you can paste the data. Okay, now I go to my Hive shell. I go to my Hive shell. I will use load data local. Actually, there are the two keywords are here, local in path and local in path and in path. So when we use local in path means I'm loading the data from local file system to Hadoop file system table, or when I'm not using local keyword, I will use only in paths, then I will give only Hadoop to Hadoop. I'm loading the data from Hadoop. So Hadoop to Hadoop means I have to do one step. First, write that file in the Hadoop, and then from Hadoop path to Hadoop. like from the Hadoop location to again Hadoop location. But local in path is directly loading data from your local file system to Hadoop. So I will be giving my local location home Arvind hive data 2. I created just now file internal.txt and into table and my table name test 1 2 3. Okay, my data is loaded. Now I can verify my select query. Okay, so my data is coming, but why it is coming null? So one row, when I created a file, so my one row is empty is there. If you see, this is a one empty row. Okay, I delete this line dd. I have deleted that row, empty row, escape colon wq. Now I want to overwrite the data. So there the two things are there, like either you want to append. So append is a default mode. So if you don't write, again you do this command again, what it will do? Again, same data will be appended, but this time null will not come. If you do select star, so again the 101 RAM test1, it is added, but this time null didn't come because the default mode is the append mode. But if I don't want to do append mode, I want to overwrite. So just I write a keyword overwrite. Okay. Now, if I see the data now, I will see only 3 rows. Okay. So load data local in path command is either we can load the data in the append mode or overwrite mode. Okay. Now your internal table is having the data. Now again we look at the our location where we have the table is created, like this test 1 2 3. So when I do this Hadoop fs minus ls, now you are able to see your internal.txt file is copied. So it is a what the file we have in my local file system. This file, the file which is in the local file system, that file is copied into my the table location folder. Table folder, it is copied. Okay, and the data in the table is coming from this particular file. Okay, so this is a way like internal table is showing the data. Okay, so this is a one way I did. Okay, I load the data using the load data local path. So suppose rather than load data local in path, if I copy this file directly in this table folder, or if I don't do this load data local in path command, so will I get it data in my table? Yes, I will get it, right? So whatever Hadoop load data local in path command is doing, if I don't do that, I just directly copy this file into my this location, I will get the data in my table, right? Okay. What I do, I create another table test 1 2 3 4. Okay. This is the internal table. Again, I'm creating this same one more internal table. Okay. Now this one, I just copy this internal.txt file. I just do Hadoop put command. Hadoop fs minus put. This is a new table, right? This is a new table. Okay. If I see the data is there or not, test 1 2 3 4. There is no data. This is a new table, right? Now what I'm going to do, I'm just copying this file test internal.txt. I'm just writing to the my this Hadoop location user hive warehouse testing.db is my database folder, then my table folder test 1 2 3 4. Okay, so I'm copying the this internal.txt file in this location. Okay, now done. Now if you go to your hive and do select command again, you will see the data, right? So this is the another way. If you don't write the load data local in path command, you can directly copy the file in the target database table folder. You will get the data into your table. Okay. Okay. If you change your file, then data will change automatically. Suppose you add more record in this file, you will get the more data. Okay. So this is the second way of copying the file into the your table location folder. This is applicable to both, either it's an internal table or external table. So external table also we load the data using load data local path command, or we can use another way is Hadoop fs. We can put the file into that external table location, right?
Is there any preferred method?
Sorry, Richard.
I say, is there any preferred method? I think the second option is much.
See, both are
easier to
good.
understand.
Okay, generally we do the highway, right? Okay, suppose we don't have access through the SDFS way to put the file. Okay, and this load data local in path command. Okay, we know the file which I want to load. I can load using the hive. So here you can use append or override. Okay, because when you are copying the file, you will not get that way. Okay, so you have to modify the entire file. Okay,
Yeah.
if you want to overwrite or append. Okay, so it will change your data. Okay. Okay, so if I drop this table, okay, now we see what happens when I drop this table. Drop. Okay, first we do external table. Okay, so if I want to create the same table as external table, so what I need to do? Okay, this is I have already written. You can follow the same instructions. So drop table. So when I'm dropping the table, drop table, and I say test 1, 2, 3, 4. Okay, now I do select command. I will not get the data because this is internal table. And even if I check the location, okay, this one, test 1, 2, 3, 4. Okay, so now this location I will see it is saying not found. Okay, because the table is deleted. So definitely the data in the table also deleted. Okay, so only testing.db you will get, because testing.db is your database folder. So database folder has other tables also. Okay, so it is there, but your particular table is deleted. Okay. Okay, now we go to the external table. Okay, so we will see the advantage of the external table. Even we are dropping table, but our data is not dropping. So same table, I'm just using the external keyword and I'm giving the location table data. So might be this location is there. So I'm just changing the table name. So test 1, 2 and table data 1, 2. So this table 1, 2 folder will be created. You don't need to create in Hadoop this location. This location will be automatically created. Whatever location you give, it will be automatically created in the Hadoop file system outside your warehouse directory. This is not a warehouse directory location. So when I create external table, now I want to see this table data. So right now nothing is there because I have not inserted anything. So insertion is the same. The load data local path command or Hadoop put command you can use. Okay, first we do Hadoop fs put command way. So Hadoop fs put command. So what I need to change here, my location is now table 1, 2. Table 1, 2. This is my location of the folder, right? So now I say, okay, file name could be anything. Okay, I just copy this file. Okay, now I go to my external table select query. Now can you check here? Okay, what is the location I given? Table data 1, 2. Okay. Actually, table 1, 2 is all table data. It should be a case sensitive, so you should see table data 1, 2. Table data 1, 2. Okay, I put the file. Okay, now I'm checking the table. Can you see the data came in the external table? Okay, the data came using the put command. Now if I use the load data local in path command, okay. Load data local in path, I'm using this load data local in path. Now my location is same, the input file location is same, the internal.txt, but here I have to change the table name. Okay, so override into table test 1, 2. So override I should not use because you will not see whether the data is. I should use append mode. Override means the existing data will be overridden and you will feel the same data is there. So that is the reason I'm going append mode into table test 1, 2. Okay. Now I see the data again in the test 1, 2. The 2 times are there, right? So here you can see data is, if you want to use override keyword, so override. Okay, so now you will see only one time 3 rows will be there because I use the override. Now we drop the table. Drop table. Okay, first we see the like show create table command. Show create table test 1 2. Okay, so you can see this is the external table. It is clearly mentioned this is the external table. Okay, and the location of the table is the table data 1 2. Now I'm dropping the table test 1 2. Okay, now I do select query. Table is not found because table is, but still data is there or not. So how to check? I will check hadoop fs minus ls slash table data 1 2. Okay, this is my location, but you will see the data still remain there. Data is not deleted. I copied the data, right? Internal.txt. So this data is still there. So I will recreate the table. I will recreate the table just running same command. I will copy this command. So that is the advantage of external table. You can recreate the table. Your table now reassociated. Now I do select star from table. Now your table is again recreated. Okay, because data is present on the same location, just table is recreated and reassociated with the data, whatever the location of the data is there. Okay, so this is the advantage of the external table. When you drop the table, your schema is deleted but not the data. Okay, so that is the benefit of external table. Okay,
When you are in internal table loading, when you are inserting second time, right? Why that nulls are coming in between?
where null came?
Internal table, when you are doing
Oh, okay,
file-
okay. Yeah. Actually, when you any blank row, if you do, then blank row will be table. Okay, I show you the file. The internal.txt file, the first time when I was like this, so I empty row will be taking as a null. So if I,
for last value. You
last
mean.
row, yeah. So
Okay,
last
okay,
row.
got it.
So yeah, now you will write it this one, control W. So you will see now I put the file. Okay. Okay, so minus F. Okay, now I see in the Hive table. That is not related internal action, it's a general behavior. So now
So the file have last value additional.
null. Yeah, null. Okay, so this is null is coming. Okay, so this is a concept of internal actional table. So next thing I am going to tell partitioning. That is a very most important concept in Hive. Okay, the partitioning, the understanding of partitioning is very important. Why we go partitioning? Okay, and when the question comes for the improvement of performance tuning in the Hive, right? Query tuning. So partitioning is one. Like we can say we can do partitioning and we can improve the performance of the queries. So first of all, we need to understand why we need partitioning and what is the use of the partitioning. Okay, so if I say in Hive, we create internal table and external table. Okay, so if you have some record like for the city, right? I'm just taking an example: ID, name, age, city. So I have a record city wise. Okay, so if I want to find any particular record I want to find for particular city, okay, I say XYZ city. Okay, so here we are clause will come. So what will happen? Generally, it will check every row. It will go check and every row city is XYZ. Then it will fetch the data, right? So it is doing the full table scan, right? Full table scan. Suppose this number of rows are there 100,000, 1 million. So you can think of the number of rows will be more, then it will be taking more time to read the data, right? So for avoiding this full table scan, Hive has suggested partitioning, a logical division of the data. Logical division of the data for the table. Okay, and we need to create a one partition table. So on top of this table, we can create a one partition table, and our partition column will be city. Now how to decide which column will be partition column? So we can say the column which has the more repeated data, like city is the more repeated data. ID will not be repeated. So name can be repeated, but generally people don't go many frequently queries on the city, not the name and age, right? Okay, but I can go for name and age also. You can create partition name and age and city on all, but you have to create a separate partition table you have to create. Okay, but here is a more like a frequently used query is a city, right? I want to some analytics I want to do based on the city. Okay, so partition column is a city because here the data is more number of time repeated, right? So this hive will do logical division of the table, logical division of the data into partitions, and these partitions can directly fetch. Like suppose I say I want to get the partition city equal to x by g. So it will not go to whole table scan. What it will do, this logical division of the data is already done. When you create a partition table, it is already formed. So whenever you say a query, select star from city xyz, so it will go to the partition and partition will be given to you. So can you tell me which one will be more faster rather than scanning the whole table, or you will be just asking partition, I need this partition, and you get the partition. That will be faster, right? But it will be taking very less fractions of seconds to give you the partition. So partition is giving you the advantage, but here are the two partitions are there, like static and dynamic. Okay, so what is a static? Static is called manual partition, the manual way we do the partition, and dynamic is the automatic. Okay, I give you the one scenario where I can go static partition. I say like when we have the less number of partition requirement. Okay, so generally city will not be this criteria, right? City will be like any table has not the one or two city. There n number of cities are there, so you will go for the dynamic option. Static you can go like, okay, gender, male and female base, you want to find the data, right? So you can go here. So in static partition, you are loading the data manually into the partition table. So first you have to create a partition table. You have to create your partition table, and this partition table you have to load data into partition table manually, like using the load data command. If you are loading from the file, load data local in path. Okay, so this is for the file when you are loading the data from the file. If you are loading the data from table, so some scenario is there, you don't have separate file, you have a one single table, all data is there, just only the where clause you use and get the data. Okay, so you can use insert into table command. So insert into table you can use to write the data into table. This is called table to table, and this is file to table, file to partition table. Okay, so the static you are loading the data manually, but here you have to do those many number of time this load data local path command or insert into command, those many number of partition you want to load. So that is the reason when the number of partitions are more, we don't go with this static. Otherwise, if I say you have 100 cities data, will you go with this load data local partition command 100 times for this static? No, right? So you will choose in that case dynamic partition. Dynamic partition is not default. Yes.
Yeah, is it the same thing as indexing or filtering, maybe? The data.
Indexing?
Yeah, or filtering the data by certain criteria, maybe city, for example, or sex, for example.
Yeah. You will be choosing the number of data based on the number of repeated data in the column. So you first identify which column is good for the partition, right? Where you need a frequently searching data, right? So you will go that column. Okay, and then static and dynamic.
You could have more than one partition then.
What are you asking?
I said you could have more than one, maybe You could have a
Yeah, partition column could be one. Yeah.
Okay.
This is a single partition column, but you could have a nested. Okay, so nested is the case. Suppose I say I have a city and I have a, okay, I just take an example of country, city and country. So
Exactly.
this combination will be there. So I say so which one is a bigger partition, right? The country is a bigger, right? Country will come first and then country has the city. So how will be
Yes.
your directory structure will be formed in Hadoop file system? So first your country folder will be there, then city will be there. Okay. So first countries will come and then each country's cities will come. So like this, it is a multi-partition column. So here when you are doing the partition by clause, here you are doing partition by, here you will provide two columns. One is country string type and city string type. Okay, so this is called nested partition. This is called nested partition. So when you're using nested partition, so you have to use in your where clause city and country both. Then you will get the advantage of the partition. If you are using only city, you will get faster, but it will be better than the non-partition table. Okay, but when you are using city, so definitely you should give the country also. So you know, right, this city in which country, so definitely you should give the country as well, correct? So then it will be more faster because it will go to the first country level partition, and within country level partition it will find the which city is a partition, then it will fetch the data. Okay, so the country is suppose PQR, this country. So it will be nested. So when you are using two columns as a partition column, it will be nested partition. Okay, but static dynamic case is related to how many number of times the partitions values are there. Okay, if partition values are less, you can go for a static. If number of partition values like 100, 200, 500, thousands, then you will never go with the static. You will go with the dynamic, because dynamic will use one single insert command, and dynamic case is not there. This file, you will go the dynamic case is you can insert thousands partitions in a one single insert command. Okay, insert into your partition table and select star from source table. You will write it. Okay, so here we have to specify the partition name, right? The partition is city like this. So here we are not specifying any particular partition name, right? Because the dynamic partition, we don't need to tell the name of the partition value. Just we tell the city, it will automatically find the different values and create the partitions. But in case of static, we have to mention when we are doing the load data local path command, or we are doing insert into table command, we have to do. Okay, I'm showing with the demonstration, then it will be more clear because partition is
Arvind, one doubt, if we are giving two columns as a partition, right? That is second level partition or it's a partition only? If we are
see
doing
first level
country and
partition, second level partition. First level is like the
country.
like whichever column you are giving first, that will be created first. So when you want to keep it here, right, country, so country you should give first in the partition by. So country you give first. So that will create it as the first, and that will be nested. So later on will be the nested one, right? So that one will be nested. Yeah, and the query doesn't matter, right? Query you can write anywhere, anyone. But when you are specifying the, because this is for the Hive understanding, because Hive is how it will understand which one you want to upper level or lower level, right? So by this partition by clause, it can understand which one you are giving first, right? Okay.
Yeah, if no, if we are giving a country and cities partition column, on top of that city, I will go with bucketing.
Bucketing, you have to use another clause, okay, clustered by into number of bucket. So that you have to add. Then bucketing is within each partition, like you want to distribute a record into set of bucket, and bucket is nothing, is a output file. I will go with that because first I let you understand this partition example, okay? Because bucketing will see, right, number of record, and bucketing is entirely different from the partition, but combination is much better, right?
Arvind,
if you
my
use
question
this
is
combination,
my question is, if the city combination Shall I go with
Mm.
the on top of city? Shall I partition that bucketing on that city column?
No, because it's a repeated. Bucketing always suggests you should use the unique column value. So either
Okay,
customer
column.
ID, order ID, which is not repeated because it is using hashing technique to generate a hash value. And based on this hash value, the data will be put in a file, in a order. Okay. So again, when you are reading, you say, okay, I want to get the city, country, and you say, and I want to ID, some particular this guy ID, I say ID equal to 5001. So in this city, country, and then ID 5001, so it will find in the this partition 5001 ID is where. So it will be more granular level, right? Okay. So
Yes.
what you are going to do when you are giving to this, again the hash value is calculated for this ID. And this column is already known column. This is a bucketed column. This is a bucketed because you are using clustered by key. So you are when you are saying clustered by ID, okay, into number of bucket, you say 32 bucket, like this you have syntax. Okay, so when you say clustered by ID, so it will identify these two column are the partition column, this column is a bucketing column, so it will treat accordingly. Partition column, it will find the partition first, and bucketing column, it will try to find which bucket this particular record is there. So suppose there are the 10 buckets are there, equal number of record. So once hash value will be giving you at the time of you are writing the record in the bucket, the same hash value will be calculated and it will find the same bucket, right? So it will be
Yeah.
more faster to read your data.
Yeah, I understood, sir.
Okay, so okay, so for partitioning, what I'm doing, first I'm showing the example with static partition from the file to table. Okay, so I'm creating a one student table, student name, father name, and percentage. 3 columns are there, and partition by I'm doing. And one more thing is, whatever partition column you are choosing, that column will not be the part of your table because that is a logical column. Okay, that will not be part of your table. Okay, so whenever we are doing a query on this column, right, where clause section equal to A, so it will give me the data of this particular partition. Okay, so first I'm going to create the section is a partition. Okay, just remember here section is a partition. Okay, and this 3 columns and 4th column is logical column, that is a partition by. Okay, so here I'm not showing the nested one. This example is pretty straightforward as a single partition column. Okay, so I'm changing the table name, might be I have not. So I created table. Now I'm going to prepare the data. 2 sections data I have to prepare. Okay. Section underscore A. This is just 2 rows data. Okay. Second file. Section underscore B. Control D. So I have the 2 files, section A, section B. So now next command is I'm loading the data into partition. Same command, whatever you use there for in the simple table, right? Without partition table, non-partition table, just only add partition and whatever the partition column value you want to give. So I want to give the partition column value A, like for section A, because I'm loading the section A file. That is the reason I'm giving here section equal to A. When I'm loading the file B, so I'm doing the section B. Okay, so these 2 load data local command I'm running. I have to change the location because this hive data 2. I think this is a bracket problem. Load data local in path. Load data local in path. Single code. Data local in path. Home hive partition. Okay, hive data 2. Into table student. Oh, where I'm running this command. And nobody is giving attention. It happens. Okay, so here I have to change my table. Table name is a student12. So student 12. So my section A file is loaded. Okay, and here it is saying load data table testing student12 partition data is loaded. Just I need to change section B and file name because table is same. Okay, section B. So this is also loaded. So now my both the files are loaded into the my table, right? Table 12. Now if I do select star student 12, so I will get all data, but particular partition data where section equal to A. So only A. This is coming from the partition. When I do B, so it is coming B. So this is the just only the use case, right? Like I just loaded the file into the table and load data local command, and then I'm just reading the data from the partition by using the where clause. Okay, so this is for the small data I showed you. You will not see the difference. Okay, even you do the non-partition and partition, it will be no difference here because it's a very small, like four record. When you have a thousands record or 10,000 and 100,000, then you will see the more difference, right? Okay, so this is just for the understanding the example. Okay, we can take it bigger file also. So if I have to load the data from the table, like some other table I have to load. So what I need to do? So I'm creating a one source table, but this source table has the section also, because I'm assuming it my section.txt file, which is having all the section data. Okay. So rather than loading from the file, I'm loading the data from one table. Okay. So this is the example of loading data from the table. So this source table I'm creating. Okay, so this source I'm creating, which is I'm loading this data section.txt. So first I'm creating a source. Okay, now I'm loading I'm just creating this file. I'm creating section.txt. Copy this data. So this is a blank line. We don't use :WQ. Now I will load first in the source. This is a general table, right? Nothing partition, no partition table. So simple command I'm using to load the data. So I've changed this location. I data to section.txt. And this is my source table name is, I created a source table with the name source 12. Source 12. Source 12. Okay, so I loading data into. So this is a non-partition table. So this will have data student underscore source 12. So this
Yes.
yeah. So now now I'm loading this data, this data to the partition table. For A will go to the A partition, B will go to the B partition. So for this, I will use insert into table, my target table, okay, my partition table. And then I say, here I'm static way defining. I'm say when the section is A, the A section data will go. When I say section B, and the where clause also I'm telling section A and section B, because in the table there's different sections data are there. So if I don't do this, where section equal to A, all data will go to the in one partition. So that mistake you should not do. You should specify the section. Okay, whichever section data is there, it will go to that particular partition. Okay, so here I will change to the my so partition table. Section A. And here I need to specify the field. So one thing is here, the last column, you keep it section here. Okay, so here, insert into table command. Source 1, 2. So if anything will be wrong, it will be giving the error. Okay, so this section is not required here. Because we are giving in the where clause, we don't need to give, but dynamic partition we have to give. So it will be running a MapReduce job. And here it will be writing the data from the section A from the table. So you've seen one thing, when we are using load data command, it is not running a MapReduce. It is directly loading because it is schema on read, right? Basically, it will be verifying the data while reading the data from the table, okay? But at the time of it is not checking. So here, now the second one I want to do, so just I will change B. And here is a B partition. Static partition is preferred like when you have the files, okay, manually you have to load the data. Okay, then you can go for static. And when you are sure like the less number of files are there, or then you can go for like. Okay, student 1, 2. So I can query select star from student 1, 2. So A, B all coming. Why it is coming 4 record of A? In my file, 2 record of A and 2 record of B. Okay, I'm using this student 1, 2 already the same table I'm using. Actually, I didn't create this second use case. I didn't create a new table. That is the reason it is added additional record. Okay, that is the reason it's coming duplicate data. Okay, if you have created new table, then you will get only the total 4 record. Okay, now 8 are coming because those are the old data. Okay, that is the reason 4 is old and 4 is new. Okay. Okay. So section 8. So it's the same thing. The select query is same. Only difference is how we are loading the data into the table. Okay. How we are loading data into the partition table. Okay. So how to use the dynamic partition? Okay. So dynamic partition. If I want to create this table to partition, dynamic partition table will be the same. Only thing is we need to enable the 2 properties. One is dynamic partition true and one is a non-static property. Non-static property is important because that will make it your table is a dynamic partition. By default is a static partition allowed because the static partition there is no need of configuration, but when you go for dynamic partition, you need to add this configuration, then you can use dynamic partition, but otherwise you cannot use dynamic partition. Okay. Okay. No, I'll go to okay. So dynamic partition. So I'm creating a one external table. Okay. And there is a partition column same as a city. Okay. Just I'm creating with the name is a dynamic partition. So I'm creating a table. So ID name. So this is my source table for the dynamic partition. So I will create a source table first. I will create a source table. Okay. This source table, I will load the data. So I will create a data. So my file name is a dynamic. I'm loading the data here. My source table. Okay, txt is there. I forgot here. Txt. Now select start from employee source. So my data is there. So I will be using city 1 and city 2 to partition as a dynamic partition. Okay. I don't enable the dynamic partition and I try to insert query. Okay. What it will say. So what I will do, I have a dynamic partition table. Okay. This is my dynamic partition table. What is the, okay. This is my dynamic partition table. So this is my dynamic partition table. I'm saying my dynamic partition table, I want to load the data partition city from this particular source table. Okay. I'm running this command, what it will say. Because I'm trying to load the data in a one single command. Okay. One single insert into command. But I have not enabled my dynamic partition. I have not enabled. So what error is coming? Dynamic partition strict mode require at least one static partition column. So either you make it your partition as a static column value, either you give the city value and then allow it as a same static partition, or turn this off and then set the dynamic partition value. Okay, if you don't want to use this static thing, so you want to use the dynamic thing, set this non-static property you have to set. So you have to set this property. You have to copy this property and set it here. And one more property you have to set it. Set hive execution dynamic partition equal to true. So this property, two properties you have to set. Now I'm running the same command. Just I set these properties. I'm trying now. Now it's running my MapReduce job. So it will fetch, if it is a city 1, it will go one partition, and city 2 partition will go. So it will create the partition. So there is a show partition table command is there. You can see how many number of partitions are created. Suppose manually you don't want to see the location. One way is you can do Hadoop fs minus ls. Okay, so what is the location of this table? What is the location of this table? You can show create table, and then you can give the table name. This is the location table. Okay, you are using show create table, so you can give the table name. The table name. So here you can see the location, and then you can run Hadoop fs minus ls. Then you can use this location demo1. Semicolon. So can you see here city, city1, city2? So this is a folder. Again, it is a folder. Okay, so this table slash city equal to city1. If you have nested partition, so then the column and column value will come. Okay, but in our case, here is the file. Here is the file. You can see this is the file 0000. If I want to see the content of this file, slash 60_0, and then I can see cat command. Press minus cat. So you see, this is city1 data, because this is city1. Here the city1 will not come, right? Because this is city1 data, so why it is? So this is the city partition. City2 you see, you will see the city2 data. This is city2. But in case of bucketing, you will have multiple files. This is the difference here. Suppose you have like more records are there and you are using the into number of bucket 2. So what it will do, it will create two file. I mean, right now you are able to see only one file. So this same data will divide into the two file. One record will go to one file and one record will go to the another file. That will be the difference in the bucketing. Right now, in case of partition, you are not using bucketing. So you are able to see only one partition file. Only one partition file you are able to see. But in case of bucketing, you will be able to see multiple files. Okay. So that will be difference. Okay. So here, what I was going to show you, what I was saying. Okay. So this one, okay, I am able to see the data. Okay. Show partition. Okay. Show partition. Table and table name. So like this way also I can see the my number of partition. Partition you can create after creating a partition table also. You can later you want to add the partition. There is a show. I think table will not come. What is my table name? This is a table name. Yeah. So can you see here, like this is showing the two partitions, city1. So it is a dynamic partition. Okay. If I do the select query, I did only one time insert, right? I did only one time insert. And now I say where city equal to city1. So only one city data I can see, right? When I do city2, select query will be the same. The only difference is coming here, insert the data into your partition table, either a static way or dynamic way. So this is a dynamic way. You are loading the data from the table. Okay. So you are doing only one single insert command. There you are specifying your partition column name city. And just remember here, the last column should be the city name, so that it will identify Okay, your partition column is city. This last column should be the partition column name, because this column is not part of the city column, is not part of your this partition table. It is a partition column, not the table column, right? It's a partition column, this city. Okay, so you are inserting the data. Okay, so you can load the data from the file also in the partition table. Okay, and there also it can run a one single command, load data local path command. Okay, so only thing is you have to configure your dynamic partition, non-strict, you have to enable. Is it clear, this one? Okay, so if you want to see the bucketing, so bucketing you have to add the clustered by key. So clustered by key you have to add, like you want to keep it ID as a clustered by key. So you can create a table with clustered by key ID and into number of bucket. So this number of bucket we can also decide based on the property, right? There is a like what is the block size, and then you can what is your total table size, then you can define the number of bucket. So you can see here how to decide. One article is there, decide number of buckets for the create table. So you can find here. So this is the way like you can calculate the number of bucket. So suppose my data size is 2300 MB, like 2.3 GB, and the block size is 128 MB, that is Hadoop 2.x block size. So you can divide that you can take it to 17.96, that is 18, and 2 की power 32 is greater than 17.96. So n5, right? So 2 की power 5, like you can say the number of bucket 32. So when you are doing a create table syntax, so in the you can specify there the number of bucket. Okay. So depending on the size of the data, you can decide the number of bucket. Okay. So create table. Let's take an example of bucketing. So you are saying here clustered by zip code you are using. So zip code is unique, right? Zip code is not repeated. So zip code you are saying into 32 bucket. So partition by you are doing state. You are saying each state state is repeated, right? So data is state wise. You want to do partition, and zip code is each state has the record. That is a one partition, and one partition is divided into the number of record in a files, that is called buckets, and that is called physical output division of the data. And zip code is here the bucketing column, that is clustered by key. So clustered by key you are defining into 32 buckets. So 32 buckets means each partition is divided into the, so one zip code, like okay, one state can have more than like it will be huge data, right? So we can say the 32 buckets, right? So 32 files will be created. Okay, so depending on the hash value, it will go to that particular bucket out of these 32 buckets. Okay, so when you are loading data, but you have to enable this property, additional property up.
बाहर में अच्छा गोवा है
Hello?
बाहर अरे वो मैं ऐसे ही बोला मैं डॉक्टर को
Okay, so this Hive enforced bucketing you have to enable, and you load the data into your like table. Once you load the data, then you will see the data look like this. So you will be seeing like this is the state is a partition, right? Same state, there n number of files are created. So this is your output file. Okay, some of the files are having 0 record because they don't have the like the depend, right? Like it will be some generally it will be equal size of the number of record, right? Okay, so hashing value all depend on the hashing value, the where the record is going. Okay, and when you are doing the select query, in the select query you are specifying the partition column and your bucketing column, and combination of that you will be. So bucketing can be allowed without partitioning also. If you don't have partitioning, you can use bucketing alone. So in that case, you will not define in your create table syntax You will not specify the partition. You will say clustered by ID into 32 bucket. So you don't have the partition, so you can directly go with bucketing as well. Okay, but bucketing will create this output files. So in that case, the partition folder will not be there. Directly your table folder have the bucketing, right? It will be having your output files. Okay, so here the bucketing will be giving an advantage, like your zip code, right? Your particular, okay, what is the bucketing column? Zip code. Yeah, particular zip code you can easily search, right? Rather than if you don't want to go for the state partition. Okay, so you can use bucketing without partitioning as well. Okay. This is clear. Okay, so if you want to create a table, you have to load the data. We can do this bucketing, but I want to tell the another thing is complex data type. Okay. Okay, we go first Hive file format. So Hive file formats, they are the different file formats are there in Hive. Okay, so generally we use CSV, JSON, XML. Okay, Hive file format. Generally we go for JSON, CSV, XML, right? So these are the file format. Okay, these are the text type file format. Okay, text type file format. Okay, so there are the another type is there like Survey, like we can use Survey, like JSON also a Survey, because if you are not able to load the data, like your data is not a simple text file format. Okay, sometimes like you have the data in the JSON. Okay, JSON file is there. Okay, or you have an XML file that you cannot load data directly into your table, because in the table command, create table command, you are providing the row format Survey and field terminated by comma, but your file is not comma delimited, right? Your file is basically the JSON file. Okay, so you have to use JSON Survey. Okay, what other file formats are there? Okay, so there are the other file formats are there, right? ORC, Avro, and Parquet. Okay, so these are the three common file format, which is compressed file format. The other file formats are, these are not compressed. These are human readable. Okay, file format. Okay, but when I talk about ORC, Avro, Parquet, these are the compressed file format, right? Suppose my data is very huge, right? And I want to have a ORC file or Avro file or Parquet file. So this compressed file format we can use. So what is the difference between the ORC, Avro, and Parquet? Okay, so ORC and Parquet, these two are columnar file format. What is the columnar and what is the row oriented file format? Row oriented file format is the file format where the data is stored in the row form. Row oriented data is stored in row oriented manner. And the column oriented where the data is stored in column oriented way. Data is stored in column oriented manner. So generally we say row oriented manner file format is faster to write. Okay, and this is faster to read. Okay, suppose my requirement is I want to read the data faster, so I will use this column oriented file format, ORC and Parquet. So generally we say like Hive is more suitable for ORC file format, and Spark is more suitable for the Parquet columnar file format. Okay, so what is the difference between the ORC and Parquet? Because both are the columnar file format. Okay, so ORC is highly compressed than the Parquet. Okay, ORC is a highly compressed. Okay, so then Parquet. And the other advantage is like ORC is good fit for the Hive, and Parquet is a good fit for the Spark. Okay, the default file format. Okay, and Parquet is having another advantage, that is Parquet is Parquet is having a nested schema support, nested schema support. So there is no need of relationships of the data. Like if I say employee with address, okay. So I can define the nested schema, right? Basically the Parquet is faster way to access employee and address information, right, in the same schema. So it's having a nested schema support is there, okay. And when I come to the Avro is very good for schema evaluation support. Schema evaluation support is very feature is required. Sometimes our schema is keep changing. Suppose I have a Hive table, I have a 3 column, A column, B column, and C column. And after some time the requirement comes, I have to add a new column, D. Okay. And this D column, I have to add in my old schema. So if I go for Parquet and ORC, it is also supporting the schema evaluation, but it is ending the schema it is adding the column in the last of the schema. You cannot add in the middle. Okay. Suppose in the column sequence, I want to add the column in the middle. So you can go for Avro, because Avro is fully schema if evaluation support is there. Fully schema evaluation support. So that is the reason we choose for this schema is keep changing. If this question comes like, if my database schema is keep changing over the time, so which file format is good? So you have to say the Avro, because other file format ORC and Parquet, they are partially supporting and they are adding on the last of the schema. Only you can add, okay, but you cannot delete, modify, and you cannot do anything in the middle, okay. So schema evaluation support is there, okay. So Avro is simply just we create table syntax and then stored as Avro. Just we write like this. So it will make it your table file format is Avro, okay. When you do Parquet, so you will do stored as Parquet. So your table file format is a Parquet. Same like a create table is stored as ORC, you can do ORC. Okay. But Avro, Parquet, ORC, you cannot directly load the data. These file format are compressed because you cannot load human readable file, you cannot load into Avro, Parquet, ORC directly. So what is the way here for these 3 particular type? So first you create a table of these particular type, create some source table, load the data into source table, load data into source table, and that source table you load insert into table, like my Avro table is there. Then say select star from my source table. So like this, you will be loading data into these all my Avro, Parquet, and ORC. So this is an indirect way you are loading data, not directly you are loading the files. My source. Okay. So this way we can use this file format type. Okay. What is a complex data type in Hive? Like we know the simple data types are there. Like generally we use string, int, double, right? Int, double, okay, short. So these are the common data type we use. These are called primitive data type. So Hive has provided one complex data type. It's a very great feature. Generally, the SQL databases, you don't get that. Suppose I have a same data type values are there, array. Suppose I say I have to store the student marks. So generally what you do in, you have to go for another table and you have a student ID and 3 subject marks. And then you do the join and then get the data for student marks. But here you don't need to go for the second table. You can define this marks as an array column. You can define marks, as an array column, and you can store the data for 3 subjects of marks, 23, 45, 67. So like these 3 subjects marks, you can store as a array, but array is the same data type is there. That is the limitation of array. Array, not limitation. I will say array is used for the same data type. So if one value is integer means all the values will be integer only. Okay, because marks is an integer here. So Hive has provided another data type is struct. Struct is a different types of data type you can use. Like suppose I say address, so address is my struct type, and this address can have city, okay, street, zip code. So I say city, street is a string type, and zip code is an integer type. Okay, so this way I can use the different data type. Another type of complex data type is their map. So map data type is key value. So suppose you want to define one person EMP object, right? EMP ID is associated with PF and EPF account. So there I can create a like this key value pair, like EMP ID is associated with the PF. EMP ID is associated with EPF. So like this, I can have the key value pair type, so I can use. Okay. So I need to prepare the file where I have these data types, and these data types like array when I'm using, it is also separating in the data with some delimited character. Okay. Suppose my general data, right? Like I say all the fields data is separated by comma. So I keep it some other delimited character for collection data type separation. If my collection data type, so how can I my Hive table identify this particular delimited character for the collection type, or this particular delimited character is for the my other fields type? Okay. Okay, this is the one blog link. Okay, so I'm just showing you the example. Here is a cat. I just created one array file. An array file data, if you see here, the fields are separated by comma, and this particular array of 3 values is separated by dollar. Okay, or you can use pipe, whatever you use, but just change here. So here you are using create table name, you are giving the field, and this is the array field name sub, sub, and you are telling here this array is a string type. Okay, and here you are saying collection item terminated by dollar. Okay, so first I create this file. I go to my, here I copy the data. Okay, so now I will create table syntax. I will create to remove this. So this is a table. The table name is tab7. Okay, now it's a simple command, load data local path command. Array file. What is my file name? Array file into tab7. Table tab7. Why it is saying I data 2. File name is same, right? Yeah. Hmm.
I think you have Hive, HIVE, instead of HIV.
What? What are you saying?
Sorry, you had HIV data one, but in your script, in your command line, you have HIV right
Hive
there.
data 2. This is my Hive data 2 folder, right? And this is also Hive data 2. I'm in the same folder, right? Hive data 2. And what I'm typing here?
But up here, up above, we have HIV E.
Oh, okay. Yeah.
Yeah.
That's the reason yeah, you caught it. Okay. So, select tab 7. So if I want to see the whole data, I will see, because my array fields data is coming in square bracket. But suppose it is individual array column value or array index value I want to read. So I will do select. Okay. So sub is a column, right? So I say sub of 0 or 1 or 2. I have to tell the index sub of bracket 1. Like these two value I want to print. Tab 7. So I'm getting this the first value and second value. Okay. And wherever the third value is not there, it will come null. Like if I print. So individual array values I can take it, index values. Okay, so this is my array type, a map and struct type. So one single example we can see for both. So if you see here is the address is a struct type. If you see here, the city is a string type, state is a string, and pin code is a big int type. Okay, because it's more than the integer limit. And here is the map type. If you see, the map type is a one, column is a field is defined DUD deduction. So that is a map type, and map type is again map type is a key is a string type and int is a value type. So if you see, the data is map keys are terminated by hash. So where is a hash is there, that is hash key terminated. But collection item terminated by dollar, it is applicable to your array as well as your struct type data. Only difference in struct type and array is the data type. So here is all values are the same type, and here the values are the mixed data type. Okay, so struct is having the mixed data type. So I have a one ID column, name column, salary column, and some this sub column is there. That is a string type, and then the map type column. This is a map type. Okay, this much. Okay, and this is a struct type. So it is having all three types are there. I create a data. First, I have to create a table. So here, so this table I'm going to create. And now I can load data, local path, I can load the data. So here I will change the file, map file, and table name is 11. And now if I do select star from tab 11, so I will get all. So here, if you see, struct type is coming in the braces. Okay, field and field value, field and field value, but array is the indexes. So it is representing index 0, index 1, and index 2. and this is a key and this is a value and this is key and value. Now, if you write a select query, I say I want to sub of 1, comma. Okay, I want to say map. Map is a type. What is a map? Is DUD. So DUD in square bracket. Okay, just remember it. Both are using square bracket, but here you are passing the key in the single quote. Okay, the key name. Here you are passing an index. That's the difference. Here you are giving key here. Okay, I want to get EPF also, EPF. Okay, and I want to access the city and pin code. So how to access? So my ADD are my object name. Okay, the struct type value, type data struct column, and then dot city and ADD are pin from tab 11. So I can see all the data. So I can see the PF, EPF, and city and pin code. Okay, so this is a way of getting the complex data type. Okay. Okay, so next thing, okay, just take a 10-minute break and then we start the JSON and the Sardis. Okay. Anyone has questions so far? No.
What I have is not a question though. Can you submit the job as a script if and run it once?
Yes. You can create a file and that
Yeah.
file name you can keep it HQL and the dollar shell you can run it as dot HQL. So that file will be run as a Hive query language. So suppose the same command, right? Whatever do you do, create command or insert command, all
Right.
command you can keep it, but keep it a semicolon in the at the end, right? Because all these command will be run one by one, and
Right.
then whatever file you created. So in SQL databases we use source command, okay, but here we have to use Hive because we want to run this file through Hive command line, right? Okay, so you when you do Hive and then you say abc.hql. Okay, so it will run your all the commands and then it will, yeah. You can do.
Thank you.
Are you guys able to hear me? Hello?
We can hear you.
Okay. Okay, the next thing I was going to tell about surveys. Okay, so JSON and CSV, Parquet, ORC. So how to create a table for those surveys. Okay. So for Parquet ORC, like I have to create a table, create table. Okay, stored as Parquet and select name, like, okay, so I can create some table, Parquet table. I can, okay, so when I do insert into table command, I can load. This is the way to load the data from the some source table to the Parquet table. Okay, so I just show you how to create Parquet. So create table. So I will use this much command, create table in Parquet table. To specify the fields. So I'm just here using the as some select query, so I can create a Parquet table from some select query, or I can define the, like using the fields I can define. So I can create some. Here I will change the name, test day Parquet. Stored as Parquet. This, I should have some source table for loading the data. Suppose I have this source table data. I'm creating the one file. Source table. Now in the source table, I will load the data. My but file name is the source. Hive data 2. Okay. Yes. Post table as the data. Now I will load this data into Parquet table. Insert into select from testing this. So same thing we will do for ORC and same thing we will do for Avro. That way we will change the create table syntax for the ORC and Parquet. Now do we'll see the same data is coming. Okay, this table has already some data that's we can from, but this is the data is loaded. Okay, so I should do it insert override. So how to do insert override? What is the mistake is there?
The word table, insert override table.
Yeah, so no
Insert override table.
into will not count. So this will override the existing data. So this way we can load the data into Parquet. So same thing we can do ORC and Avro. So another type is okay, we can use the JSON survey. So for JSON survey, we have to download the jar. So this particular jar we have to download, and this jar we will download, and then we have to add jar, and then we can load the data from the JSON. Okay, so we have to download the jar. So it is using some UDF, right? So like UDF we use for the jar, right? We create our own custom UDF, we create a jar. The same way we are creating here the jar. We are downloading the existing jar. Okay, so somebody has already created UDF in that jar. So that is the reason we are able to use that. So we go here, this jar we extract. In this jar, this particular jar, we keep it in some location. I copy in some location. I have a jar folder. So this particular jar, I will register it first. So I will find the location and hive add jar command. I will register it, add jar, and I give the location. So I have to jar, I have to register. So once this jar is registered, okay, I have to create a table. I will create a table. So this is a complex, okay. So this is one external table I'm creating. So these are the two fields, and here I'm using the JSON Saturday type. So row format Saturday, I have to specify the type is a Saturday type, JSON Saturday class, and the location I'm giving where I want to store this data. Creating a table. So once this table is created, the load data local path command is same. So that load data local path command we have to use to, or Hadoop fs minus put, we can put this JSON file. So first we have to create this data, this JSON data. So I will create a JSON file. JSON. Okay. Now this JSON file, I have to load into my, or I can directly place into the location where my table, or I can use the load data local path command. I used load data path, my location. Test.json is a file into table. Table name is test_3. Now I see the data in my table. Test_3. So I'm able to get data. So this is the one example. Another one is suppose my JSON file is having this type of nested data is there, like array data is there. So complex data type table I have to create. So this is my data. So I create one table out. So I will go to here and add test1.json. Now I will create a table for this. So what is the table command? Test nested is a command. So I just given some name, test nested one. And this one is having one field is a Boolean type, true or false. One field is an array type, which is having the array of string values. One is a double and one is a string. So I'm creating this table. So I go to the Hive shell. Okay, now we do, what is the location of the table? This is the internal table location, right? So we can do Hadoop fs put command. So fs minus put. So my file name is a test1.json. And the location is user I warehouse / testing.db / what is the table name? Test nested one. So nested one. So I have written the data in this file. I copied the file. Now I check my table. Like start from test nested. So I'm getting the data. Now I can fetch the data by indexes. So I can do it. Okay, so that is basically nested JSON. Okay, so this is the example for the JSON. Okay. Other complex data type like XML also we can do. So there is a XML Saturday. Okay, one is a open CSV Saturday. So like you have a double quotes, comma separated data is there. So you can use this open CSV Saturday. Okay, so this example also you can do. So next one is a UDF. Okay, so what is a Hive UDF? Okay, so UDF is like our own custom functions, right? I can create my own custom function. Generally, the system functions are there, like date function, string functions. Okay, but I can create my own functions. Like I want to change, I want to like change the logic, right? I want to perform my logic, right? So like find occurrence of the word, right? So I have a one long string and one small string. I want to write a one function, and there I want to find the number of occurrence of the small string in the long string. Okay, so I can write some function as a class, and then I can regex pattern logic I can write. Okay, so that way, and then this is the Java project. So how to create a Java project? So I have to start the IntelliJ. In here we are creating a Java project. So I'm ready to test it. So already one project is created. I will show you how to create a Maven project. You can create a Maven project and you can write your own custom UDF class and you will extend the UDF. So UDF is provided by the, hello? Okay, so so we can create our own custom class and we can extend UDF, and we have a evaluate function. Evaluate function, we have to write a logic. So if you see here, this is a uppercase, right? Like I want to write logic, right? I want to do the first letter of the word. I want to make it uppercase. Okay. So for that, what I done here, I found the character at 0, the index 0 position, and I took it as a string, and then I am just making it uppercase. So first I'm just converting uppercase, and rest of the letters after the first letter, like substring. So I'm appending as a full string. So I will see the first letter is upper and the other letters will be the smaller case. Okay. So I created, and POM, if you see what are the dependency jar you need for UDF, so you should have Hadoop jar, you need it because that is for Hadoop project, like Hive execution 3.1.3. So this is required for the UDF. Okay, like for the Hive dependency libraries you need. So you need this dependency. So when you create a new project, you will have to add this all dependencies in your new project POM. So you can create file, new, you can create some new Java project. It's a Java project. And this is Maven project you will create. So Maven archetype, you are selecting the Maven archetype. So here you select the quick start. So Maven quick start type you will be selecting Maven archetype quick start. Okay. And this is taking your JDK, and here you have to give the project name. So UDF. Okay. And I'm creating a new project. Is asking this window or new window. I say new window. So this is your basic POM will be there. Okay, so there will be no dependency because you have to add dependency manually, and there will be no classes. You have to add in the source, you have to add a new class. So first I just copy the dependency from my older project. So I copy this all dependency. There's a dependency tag. In the dependency tag, we will add the dependency. Dependency tag is not there, so I have to add dependency. So I copy paste this dependencies and dependencies having the dependency. Okay. Read loaded later. Now I copy paste it. So now this has the source class, source package. So here I will create my one class. So I say this is my custom UDF class, the Java class I'm creating. Here I can give the name my UDF. So this will be your main class. So this main class will, okay, first of all, this will extend UDF. UDF is provided by the Hive, okay, and you have to override the evaluate function. Okay. So first we create a Java class, and this class will extend UDF, and then we will write a logic here in this UDF. So I will be having, so this is not required the main function, just you have to override the evaluate function, because this class will be extending UDF and you have evaluate function to override. Okay, so then we will create this project jar. I will create a jar project. Okay, so I want to use this logic as a my UDF function logic. Okay, I want to use this function logic as a my UDF function logic. So I will export, I will create a jar. So I will use this Maven. So I will create here ambient clean install. So in the Maven, you go here. And give the command here. Taxing the JDK 1.x. So first of all, what I need to do, I have to register this jar, same like I did for the JSON survey. I will create a temporary function, and that temporary function I will use in my SQL query. Okay, so that is the way to use the UDF. Okay, so first I created a project, I extend with the UDF, I override the evaluate function with my logic, and then I will create a jar, I will register this jar, and this I will create a temporary function. Then I can use the temporary function in my SQL query. Okay, now I create a jar here. So you can write any logic, like suppose you are passing the two parameter, find the occurrences, right? Okay, so you can write your that logic also you can write. Okay, so you have to use some regex pattern you can use, and then you can how many number of times that particular string is there in the longer string, so you can find it out. It's giving compilation error.
You have not imported the UDF in.
Yeah, actually now I'm just doing this Maven reload project. So this will do. So now actually it is. Project was not compiled. That's the reason it was not giving error. So now once the jar will come, so the import statement will come. I show from here. Taking time. Yeah, now it's coming error. So I have to do alt enter. Alt enter. So this is data jar. The jar is created in the target. Location. I will register the jar. Jar. We have to create a temporary function. As then I can give the package. So the package is, so this is up to see, because this is the one I did. Yes. For the example, and my UDF is a class. Now I just take it any select query. Okay, so I have the select query where the string column is there. I can apply. Name column, select upper one, name. But here is already coming, right? So how can I say? Yeah. So like this, it will work. If I don't have the table also, I can test it, right? So this is H is become capital. So this is the UDF is working. Okay. So next is okay, Hive. There are many more things, but I cover the flume and the one is hbase. Okay, the flume I just show like what is the installation is easy. Just you have to download flume, and I have already done, and I will show the flume command how to run. Okay, so flume ng. Okay, so first I have to copy the flume bin directory, right? Bin. Well, so here I have okay, flume I have not okay, yeah, flume 1 point. So this one flume 1.11.0. So this one I have downloaded, and I can run the flume ng command. Flume -ng. So I have set the version. I have already set my bash rc. DSHRC. So download the flume 1.11 zip tar file and unzip and copy into the software and then set the flume path. Okay, so this is the flume path I set it. And after that, you can start the flume. Okay. So how to use the flume? So there is a conf folder. In the conf folder, we have to create configuration file. Suppose I want to read the data from Twitter, or I want to copy the file from the local file system to Hadoop file system. So there is a spool dir is there. So in Flume, there are the three component are there. Three, it is divided into the three parts. So one is source, channel, and sink. Source from where the data is coming, channel is a medium, and the sink is final destination. So here, when I say when I'm reading the data from the file and write the data to the Hadoop file system, so I'm defining the spool dir. So spool dir is the type of the source, and the location of the spool dir. I'm showing some location. So from this location, how many files I copy? So those files will be copied into the flume this directory. Okay, so suppose I change to some new directory. And this one will create a one spool dir directory, and that spool dir directory, it will write the data. Okay, so when I start the flume ng command, it will start reading the file from the source location and write to the target location. Okay, so first we have to create this configuration file, and this configuration file will save it, and then we will run the flume ng command. So what is the flume ng command I have to run? So I have to specify flume ng agent and console configuration, the location of the flume configuration file, and then agent. Okay, what is the agent? Okay, so this I will run on the. So I have to go to the flume directory. What is the location I'm giving here? So this is schooldir.conf. So I will run this flume ng command here. But before that, I just, in my home folder, there is a spool dir folder, this one. So this is already completed one. I place the new file. So I just take it some new file. And these files I will place in my spool dir. Okay. So now this files I want to transfer to the Hadoop file system using the flume. So flume is using here the spool dir source and spool dir source type. And there is we are defining once it is completed, it will be having a suffix dot completed. And what is the directory in Hadoop file system flume 4 directory? It will create a spool dir folder. Okay. And then it will write the data there. Okay. So I will run the command. Okay, I go to my source folder. Can you see here all are the completed? So now I have to check my target location, my Hadoop file system location. Hadoop fs minus ls flum4. And this one is created spool underscore area. This created, I just stop it. So here, if you see cat command, Hadoop fs minus cat, then you can see the content. So you can see the content, all the files, whatever files is there. So all files data is in one single file, it is done. Okay, so we have to separate it, but all the files you have copied. Okay, so this is the one example. So other example is Twitter one, but Twitter one is a very, we need to set all this consumer secret key. So one other example I take it like I have to netcat telnet one. So I can type in the network something and then I will receive in the my Hadoop file system. So I will have already this netcat.conf file. Okay, I have to start this curl command to start my telnet. Okay, and which port I'm listening here, I'm specifying here, and type is source type is a netcat type. Okay, so I'm starting my curl. So I should have curl running. Telnet problem. So I will change the port. Flume configuration. Okay, 99 is there. Okay, so I just run this one. Why it is not? I not found exception. No configuration, but it is saying configuration is not provided. This now is a different netcat form. Okay, so looking for home Irving softwares. Oh, okay. Now it's a different table. It is not able to bind. The address is already in use. Okay, now I start the terminal. I think this command we cannot use because this is terminal. Yeah, so this is message coming. So like this way we can do the communication with the terminal. Okay, so we can use the flume. Okay. So one thing is hbase also. So I just show the installation and then you can practice the command. So hbase installation. So we have to download the hbase binary file. So 2.5.3 is a binary zip file. Okay, so we can hbase 2. When you go to here hbase distribution, so this hbase binary tar file, this we can download it. So I have already downloaded in mine one. So I just show you the quickly installation. So here in the software folder, I kept it my hbase 2.5.3. Okay, so this hbase I have to move it to the user local hbase. Okay, so I will be moving to the hbase this directory, the installation. So I have to user local hbase. cp user local slash hbase. Place please get it. So here is your complete installation, like conf directory is there. So in this conf directory, we have a file hbase site.xml. We have to modify that hbase site.xml. So in the hbase site.xml, we have to add this our root directory of the hbase and the zookeeper property. This properties information, we will add it. So first we have to add in nano bash rc. I have to add this home path, okay, and bin path, and I have to export Java home. I have to add in the hbase env.sh file and hbase site.xml. Before adding this path, I have to create a directory in Hadoop. So I have created this is my local folder. Okay, So this local folder, I created two directories, one for the hbase h file, which is storing the hbase data, and zookeeper is keeping like as a coordination service. So this is containing the zookeeper data. And once this one, then we will be adding this property into the hbase. So these two property I have to add, the zookeeper property directory, and one is the hbase root directory. Once this is done, I have to go to the root, and then I have to start the hbase service. Okay, so I have to go to root su minus. Here you have to go to the your installation folder, usr local hbase and bin, and we have to start hbase. And once after start this, then we exit from here, and then we start hbase shell. So it will give me the hbase shell. Then I can run my hbase command line interface, like I can run the command. So I will do list command. It will show me my tables. So already I have created table. So when I want to, so hbase is having the column family. So when I want to create a table, so we give the new table name, and then comma, give the column family, personal detail. Okay, so like this, I can create a new table. And this table is created, then you can do list, and then you can see the table. When you do scan command, I can see the emp1, then it will show me the data. But right now there is no row and no column family data. So I have to use the put command. So I just quickly show you how to write the data and how to. So hbase, like when I create a table, then I can use the put command to write the data. Okay, so suppose this is a column family, personal data and professional data. So I'm creating a new table. Okay, emp2 is created. Now I want to write in this table this 4 record. So it's a dynamic schema. So if some column you don't want to give the value, so it will not take that particular column family data. So if you say emp2 has a row ID is 1, so row ID is you can easily uniquely identify the row. So row ID 1 has the 2 column family, right? Personal and professional. Personal data has column name, and personal data has another column is city, and professional data having designation is a column and value is manager. Okay, so this is the hard-coded way we are writing data. We can use programmatic way. We have to use Java API. Like I have inserted data for one row ID for one column family, one particular column. Okay, and now I do scan command. I do emp comma. Okay, so scan. Okay, this is emp2. So emp2 is having, this is a row. And if I use a get command will be specific row column family, you can get the data. Say emp2, and you want to get row ID 1 data. So only row ID 1 data you will get. If you say row ID 1 comma specific column family data, so you can specify your column family and you can get the data. The scan command is giving the whole data, but get command, you can get the specific row and column family. You can specify a specific column of row family column, you can get the data. So you can get command.
So if I may ask you, in the create table here, just no need to define the types.
Yeah, no need to. This is the dynamic schema. No need to define anything.
Just create a table name. Okay.
Yeah. I'm given wrong. So when you define your get, and then you are giving table name and row ID. Okay, here I did mistake in this person, so I came out. Okay, so I have to start again. So unexpected identifier. So you should give the correct column family, correct column, then you will get the data from that particular table. So other commands also there, like there are the drop table, and you can follow one tutorial point hbase. So there is all commands are there, so you can practice this. So here, like you can create a table, drop a table, update data, read data, scan, count. Like suppose I want to find the how many number of record count. So just simply you do count emp. So you will get the number 2, right? You want to truncate the data. You want to remove all the data from your table, right? But this data will not be rolled back. Okay. So that is truncate command you can use. Okay, but whenever it is doing truncate, it is doing disabling the table. So you cannot drop the table directly. You have to disable table first. So there is a enable disable command is there. So disable command is just disable table. So it will disable your table. Then you can drop the table. Okay. But truncate is disabling the table and then dropping the table. Okay. Enabling table, enable table, it will enable the table. You cannot do scan without doing the enable table. If you have once disabled table and then you do scan, you will not get the data. Okay. So this is like a table level restrictions can be applied by the admin. Okay. So suppose this particular table, I don't have access. I cannot see. So this table will be disabled for me. So I can check whether the table is disabled or not. So is disabled is a command to check whether the table is disabled or not. If you want to disable all table by regular expression, you can use wildcard character. You can disable. Okay. Okay, I will give the notes on these things, and you can start. You can install the hbase and then do practice further. So hbase is a column family. I just give the brief idea about this. Hbase is a NoSQL database. So what is the limitation in the SQL databases? Right, we cannot share the data across the nodes, but hbase can be multi-clustered. Right, it can be the data can be shared in the multiple node in a one cluster. Okay, and hbase has architecture. Right, hbase is having a region server and master server. The master slave architecture. So master server is having region server, and region server having multiple regions. Region server having multiple regions. Okay. So data is shared in multiple regions. Okay. And there is a MAM table and cache, MAM table and disk table, like cache is maintained. Okay. If you see in the architecture in the HBase, here there's a master and region servers are there. Okay, so region server is allocating the data to the regions. Okay, region server. Okay, and each region server, each region has the MAM store. MAM store for memory storage, and H file is a disk storage. So have you seen that we configured in the beginning H file, right? Location. So H file is a disk storage location where the data is stored in HDFS. MAM storage is the memory storage. So initial data comes in the, like, there is a one wall is there, write head log. So okay, in this architecture is not there. Okay. So there is a wall concept is there. What is the wall? Wall is a write head log. Initially, the temporary data comes in the wall, write head log, and that will transfer the data in the memory. Once the memory is full, then the data will be going to the wall is here. So write head log, so H log. So H log is a storage file, but wall is here in this diagram also. Wall is not there. like this. This is the wall. So initially, when the master server is communicating to the region server, so region server, initially the data comes to the wall, and then it will go to the mem store. And once the mem store is full, then the data will be flushed to the H file. So this is the architecture. The HBase architecture has master server and region server. Master server and region server, how they are communicating to each other? Through zookeeper. So zookeeper is here for the high availability. If any region server is down, so the zookeeper has the information about the this master region server communication. So master is communicating to the zookeeper and find the another region server. If any particular region server region is down, so it will be finding through the zookeeper. Okay. So this is the high level architecture between the all the component of the HBase. Okay. Okay, I will share this documents file and one ebook I have for the HBase if you go through. So HBase follows the CAP theorem. Just remember it, like we have in SQL, we have ACID property. We know as atomicity, consistency, isolation, durability. But in the HBase is a NoSQL database. Any NoSQL database is following the CAP theorem. Okay, so CAP theorem is basically consistency, availability, and partition tolerance. So these are the three properties. Any NoSQL database should follow at least two properties. So if I say, so HBase comes in which category here? So you can easily see here, HBase is coming in the CP, consistency and partition tolerance. So when consistency and partition tolerance properties are followed by HBase, so HBase is NoSQL database. Cassandra is following AP. Other traditional SQL databases having the availability and consistency, because ACID, this is a part of ACID, right? So availability and consistency. Okay, this is ACID property, right? The SQL, and partition tolerant is the CAP, right? So this is pure NoSQL databases: HBase, Mongo, Redis, CouchDB, DynamoDB. Okay, so this follow. Okay, anyone has any question?
Yes, I do. Yes, I do.
Yeah, yeah, tell me.
Not with what we've just done before you leave on Hive. The installation towards the end, the DBFS. Do you have maybe? I don't know why it's giving me a problem there.
You mean to say your installation?
Yes, towards the end of the Hive. Yes, on the DBFS allocation.
Okay, I will check it. I will check it separately. Okay. Okay, thanks everyone. I'll share the recording. Yeah, thank you.